Chapter 3, The World of Numbers. We are going to discuss today the density of rational numbers. The word dense means a lot of information in small space, but the exact meaning of dense depends upon the context in which we use. So here we are using the word dense in terms of numbers, especially for rational numbers. So density of rational numbers, it means rational numbers are dense, but where? Between two numbers there are so many rational numbers. This is the meaning of the density of rational numbers. The density of rational numbers between any two rational numbers a and b, there always exists a rational number a plus b divided by 2. We have any two rational number a and b. Obviously, they are distinct. Maybe a is less than b or a is greater than b. We have this inequality a is less than a plus b divided by 2 less than b. A plus b by 2, is it a rational number? Yes, because as a and b are rational numbers, so by closureness a plus b also a rational number. That's why a plus b divided by 2 is also rational number. So this tells us existence of rational numbers between any two rational numbers. Now, how the concept of dense related with rational numbers? As we see, between a and b we have one rational numbers. Again, a plus b by 2 is rational number. Then we can have rational number between these two numbers, a and a plus b divided by 2. Also, we can have rational number between these two number, a plus b divided by 2 and b. So here again, suppose rational number is, say, c lies in between a and a plus b divided by 2. Again, we can have a one rational number between a and c, again in between this. Let's have a number line to demonstrate whatever we discuss. First, we have two rational numbers 1 and 2. By using average method, we found another rational number between 1 and 2, that is 3 by 2. Now, we got two intervals. First one is 1 and 3 by 2, and second one is 3 by 2 to 2. In between them, means between 1 and 3 by 2, we have another rational number 1 plus 3 by 2 divided by 2, which is equal to 5 by 4. We can find rational number between 3 by 2 and 2, which is a 7 by 4. After finding rational number between 1 and 3 by 2, again we will get two intervals 1 and 5 by 4, 5 by 4 and 3 by 2. And between the interval 3 by 2 and 2, we got a rational number 7 by 4. Again, we got two intervals 3 by 2 and 7 by 4, 7 by 4 and 2. So, how many intervals we have now? 1, 2, 3, 4. Again, between this interval, we find here another number. In between this interval, another number. In between this interval, another number. In between this interval, another number. Again, we'll got interval. We have one of the most magical properties of rational numbers, which says rational numbers are dense, because between two rational numbers we can have so many interval. If we find one rational number between two rational number, then we got two intervals. For every rational number we got two intervals. That's why we can say rational numbers are dense. Also, we conclude that there are infinitely many rational numbers between two rational numbers. Between 1 and 2, we found first 3 by 2, then between 1 and 3 by 2, we found 5 by 4, and between 3 by 2 and 2, we found 7 by 4. So, again, we got some intervals. So, that's why we can say there are infinitely many rational numbers between two rational numbers. So, this number line is full of rational number. If we touch, suppose I am touching this number line here, so here is also, it represents one of the rational numbers. So there is a one-to-one correspondence between this point and that line. If I choose this point, then here also we have one rational number. So every point on number line is representing rational number. We can find out rational numbers as many as possible between two rational numbers with the help of this average method, a plus b divided by 2, which is lies in between a and b. Okay, here a and b, obviously they are distinct. So remember this for finding rational numbers between two rational numbers. Thank you.